Hello everyone, in this video I'll demonstrate how to perform constrained delegation attack from Linux to impersonate any user or device where our account has been delegated. This attack can also be performed for Windows, but I'll cover this in a separate video as I don't want this video to be too long. And I'll also show you a way to reduce risk if you have to have constrained delegation configured in your environment, or how to also practical defenses you can apply in your environment. So first, let's dive into explanation. What is constrained delegation? And I'll also show you all the tabs right now. I'll just go to the Microsoft article. Here it also explains it pretty well. You can find it just by Googling constrained delegation. So essentially, constrained delegation was developed as a more secure alternative to unconstrained delegation, which was the very first one. We covered it in a previous delegation attack video. I'll link it somewhere in the description so you could take a look. It allows the service to act on behalf of the other users for a specific service only. A good example would be a web application. For example, I got a screenshot from CrowdStrike, so I got a web application that needs to impersonate users on a database. So here we would configure constrained delegation for the web app, and it would make a request to the database on behalf of the user with the user's permissions to ensure less privilege. Yeah, that's kind of how it works. Basically, this app is going to impersonate user to request database permissions for the backend service. And let's go back real quick to show you how it's configured. So I got my user pparker here. If we go to delegation, here it is. And the danger here is that if we compromise an account with constrained delegation, we can delegate authentication to any service offered by the account with the authorized list in the authorized list, because the SPN part of the ticket is not actually encrypted and can be changed without invalidating the ticket itself. Basically, how constrained delegation works, usually we delegate to specific service. For example, you can see this is host on a high-latency computer, which is the main environment, but it's not restricted to that. You can change SPN to whatever you want. Like it can be CIFS, which is going to be SMB, or it can be HTTP, which is going to be winrm. So it doesn't matter what SPN set. If we compromise pparker, we can actually request any service of high latency. And there's another cool feature. If we look in here, you have use Kerberos only and use any authentication protocol. If the constrained delegation allows protocol transition, which is what is set by this tab right here, use any authentication protocol, this actually sets protocol transition. We can actually impersonate any given user in the domain to that service. So, which is pretty cool. How it kind of works is with constrained delegation, they added this new two extensions. I just will go back to Microsoft articles. S4U2Self and S4U2Proxy. You can Google it and read up on it. Basically, how it works in constrained delegation, it would forward the full TGT for the user, like taking a ticket. Essentially, hey, here's full ticket. You just use it to request any services. With these two extensions, S4U2Self request an actual TJS, basically service ticket instead of the actual TGT, and S4U2Proxy actually forwards it to a different service that the user requested. So just instead of forwarding the TGT, it requests a TJS for the user and forwards it to the actual application. So we don't forward the TGT, we forward the TJS, which is actually more secure and was a good way of doing it, but you know, bad guys always find a workaround. All right, so let's get into the attack itself. High-level steps is we'll focus on the user on the constrained delegation that has protocol transition in place. There's also a way to abuse it without protocol transition, which I'll give you an article to read about it, or I'll maybe do a video later on how to abuse it. So our high-level steps for the attack would look like this. We compromise a user in a machine that has constrained delegation configured. In our case, it's going to be pparker. We're going to pretend we compromise this user, and this user has constrained delegation configured to the domain controller. I'm going to use those S4U2Self and S4U2Proxy extensions to obtain a service ticket as an elevated user to delegate resource. So basically, we'll impersonate an administrator for CIFS service to the height IDC, to the domain controller, and we'll pretend to be an admin. So let's dive in. So here I have my user P Parker that we've compromised and has constrained delegation. Here's how we can enumerate this. There are a couple of ways to do this. First one I'll show you is using netexec, which is very easy. Find misconfigured delegations. Syntax goes like this. Basically, we need to query LDAP. We give it host of our DC, username, password, and dash find dash delegation flag, which is actually gonna look for those delegations. And here we have it. So we have this from previous video. We're focusing on this one, P Parker person and constrained delegation with protocol transition. This is what we're looking for. This means we can impersonate any user for any service. And our delegation rights is to hide IDC. Another way to do this is to use an impacket find delegation.py script, which just goes like this. We just give it find delegation.py, we give it domain. Make sure the domain is in your host file, otherwise it's not gonna work, and you'll have to specify the domain controller's IP. And we give it username and password. And here we go. And here we have it. P Parker has constrained delegation protocol transition to hide IDC. Essentially the same output. Alright, next step is this a little bit tricky because it's a lab environment. We do need to add this SPN, service principal name, to our user if a user doesn't already have one. Usually if a user has constrained delegation configured, they would have an SPN, but in my lab environment, the user doesn't, so I would have to add this. Keep in mind that this requires extra permission by default. Users cannot modify their own SPNs, only computers can. So we'll just have to add an SPN. I did grant this user generic right on itself, so we could do that. I'm gonna use add SPNs.py from Kerberos X GitHub repo. If I go here, X. This is the repository you would have to call it. It's from Derjan. Probably mispronounced it, but yeah, you just have to clone this repo and here it is, add SPNs.py. So the syntax goes like this. We just call add SPNs.py and we specify our user, our password. We specify an SPN for our user. And we need to specify target type, which is going to be SAM name in our case, and DC IP. There you go. Oh, probably already. Actually, I already added SPN, so we can skip this step here. Actually, let's clean it up and I'll add again. I'll just clean it up. This to remove, we just specify -r flag. It's gonna remove it. And we'll edit. And here we go. Now we got the SPN our user. And you can query it to make sure SPN is set. I'll just test this input because I'm sure it worked. So now we can obtain service ticket on behalf of administrator using P Parker's credentials. Remember, because we have constrained delegation with protocol transition, we actually can impersonate other users. And we're gonna use impackets get service ticket.py for this. So specify the SPN. This could be the same one as configured in our delegation rights, so it must match. And make sure you have all the Kerberos setup for Linux. Then specify alt service, which is going to be the actual SPN we want to spoof. And well, let's just actually add to our ticket. We're gonna request an SPN CFS, which is going to be SMB, and our domain controller FQDN. Next, we just specify our username and password for a user, and the user wanted to impersonate, which is going to be the administrator. So hit go. And we can see we got a ticket that impersonates administrator on the DC. So what we have to do now is export it to our KRB5cc name variable, which basically holds the tickets for Kerberos authentication. Export. Prior to that, make sure you have your kerb5.conf set to your domain. In my previous video, which I'll link below, I show how to set and how to configure Kerberos, how to configure your Linux system to use Kerberos authentication. So it's gonna be linked in the description. Just go watch that if you want to learn how to do that. So now that we have the ticket, we can actually use it with Impacket to connect as admin using psexec, or we can do a secrets dump to dump NTDS that did. So let's do that. And here we go, we got all the hashes. And remember our user, P Parker, like we don't have any special privileges. If I click on member of, it's a regular domain user account, nothing else, but this delegation was very dangerous. And because it has protocol transition, we're able to abuse it and become an administrator. You can also use W in my exec to show you my permissions. And boom, we're Marvel administrator, which is the main admin. So yeah, that was pretty cool. Now let's just do some cleanup and remove the actual SPN because I don't need it from our user. And yeah, that's the attack. There are more delegation scenarios that you can read about in this article by Black Hills, which was pretty cool. It goes into all different ways how you can abuse it from Linux. And the part I want to highlight is this one. Is how to abuse it when protocol transition is not enabled. So we did, because our protocol transition is enabled, it's much easier. There's also something called reflective resource-based constrained delegation, and they go into a lot of details how to abuse it, which is pretty cool. And I might do a video on this in the future. But yeah, now let's talk about defenses. So what can we do as a defender? We need to have this delegation and have this user. Let's go back. So number one thing we can do is actually protect this account. So make sure it's treated as a tier 0 or tier 1 asset. And it's hard to get to it, like it sees in strong password. There are no ACLs on it from regular users. Basically follow principles of least privileges and hide tier 0, tier 1 accounts. Next one is to not enable protocol transition, although I showed you there's still a way to abuse it. It is actually much harder, and there are more conditions in place that need to be met to abuse it. So just go here and set to use Kerberos only instead of using protocol transition. Why? And the same attack will not work anymore. I think the tab disappeared, but yeah. Set it to disable protocol transition. It's gonna be much more secure. And last one is what you can do is actually mark your tier 1, tier 0 accounts as sensitive and cannot be delegated. It's the check in this checkbox. And what this does is it basically prevents any kind of delegation from impersonating the user. So this as service ticket should not be requested for this user because it cannot be impersonated. And mark all your tier 1, tier 0 assets like this. One word of caution, I think for default administrator account, it still doesn't work. I'm not sure if Microsoft has fixed it, but last time I looked, it wasn't working. And it also doesn't work for domain controllers. If you want to mark, for example, your DC as sensitive and cannot be delegated, it's not going to work because it doesn't work for machine accounts, even though the option's there, which is kind of weird. But yeah, that's all for this video. I hope you enjoyed it. Give it a like and subscribe, and I'll see you in the next one. Take care.